Hello and welcome to our last session today. Let's talk about why structured content is maybe more than you think. If we talk about structured content, we mostly think about documentation, and of course that's the basic form of our work. And now let's see how we maybe can go from a structured documentation to a process configuration. That's what I want to show you, and our topic will be a little bit data basic. So we will talk about what is specialization and why do we need specialization, and after that let's go to a sample that we are currently implementing for our tools to connect our documentation with our software or web interfaces. So one few words to me and about CRX.net GmbH. I'm Markus Wiedenmaier. I'm CEO of the CRX.net GmbH. We are located in Germany, in the south of Germany, near the Lake of Constance. And we have two software modules in the cloud. One is DTS, which is digital transformation service. So we convert any format to any other format. So we can convert Word, InDesign, FrameMaker, any unstructured document like ASCII-Doc or MacDocs or Markdown to DITA, and from there to FrameMaker or to Word, or we do a lot of things at the moment with AI and mostly with machine translation. And and what we do is not simply convert a Word document to another format. We extract information as a rule-based engine, and then we send this to our own information delivery service, which is based on IRDS, but we can also deliver content to any other system like AEM guides or so. And this is pretty cool. So, and this graphic shows what, or symbolize what we do. On the left side, we handle formats like Word, InDesign, or XML, and FrameMaker, of course, but also any other unstructured documents. We have support of 20 plus formats at the moment, but we also integrate data services like OpenAI or Congruity, DeepL, and other data services, which helps us to automate data processing. IRDS is a main part besides DITA, of course. DITA is the core of our system, and IRDS is the result when it goes to information delivery. IRDS is a standard defined by TCOM in Germany and addresses Industry 4.0 use cases and delivery scenarios based on metadata and knowledge graphs. So the agenda today, I told you at the beginning, is about specialization. So let's talk about what is specialization. Maybe you can think about why you don't specialize your data structures when I talk about that, and how we can create a custom document topic type, and how specialization works in processes. And then I have a topic which I call documentation first, and as everything is first, why should not be documentation comes first before functionality. So documentation is ready before functionality is there. So that's a nice approach and thinking. But of course, we are talking about an holistic approach, and nothing is first. But let's have this topic here, and then, of course, a summarization at the end of this talk. A few days ago, there was a question on LinkedIn in the DITA forum, and there was a question why there is no T-foot element, no footer, table footer in the data structure defined. So I tried to ask ChatGPT to answer this question, and I was surprised that I couldn't have said it better than ChatGPT does. So first thing, the first answer is that he recognizes there is no T-food element in the table. So and that's correct. DITA supports only T-head, so a table header, and T-body, so table body, but no footer table elements. And then ChatGPT answers that DITA doesn't include the T-food element, as it could be because it was terminated that the feature wasn't necessary for the kinds of documents that DITA is used to create. So in other words, it's by design. So anyone who decided to define the table structure for DITA, he decides that it is based on Carl's table model, but he reduces that and does not support, include the T-food element or exclude the T-food element, let's say it that way, for some reason. So it's a design decision. So very great answer, I think. And the other thing is about specialization. It's important to note that DITA is customizable framework. Specialized DTD, document type definitions, or XML schemas can be created to add a T-food feature if it's needed for a specific application. So in other words, if you need a T-food element, DITA says specialize the TTD, and then you can have this T-food element and work with the table footer in your custom document type. So that's what ChatGPT says. And let's have a look at the DITA standard. What says the DITA standard about specialization? DITA is designed for creating new document types and describing new information domains based on existing types and domains. So DITA is designed to specialize. If I talk to our customers or to some customers, which are mine, because mine are always get specialized DITA environment, they told me no, they don't want to specialize DITA because there is so much effort to do and maintain this stuff, and they want to keep with the standard or stay with the standard and use the standard as it is because they have bad experiences in the past to get customized stuff maintained. But DITA is designed to specialize, and that's in the very beginning of the documentation. And this means that you are always with the standard, even if you specialize. So you don't have a custom XML environment, you have a standard environment because DITA, the basic of DITA is specialization and to fit document types for your needs. And that's where there is the word Darwin in DITA. So DITA stands for Darwin Information Type Architecture, and Charles Darwin stands for specialization. So specialization of different species. Okay, let's go for the process for creating new types and domains is called specialization. So if we do, if we create new topic types, as we will do it later, we are talking about specialization. And this is similar to how classes in an object-oriented system can be inherited, the methods of ancestor classes. So what does this mean? So this is similar to how classes in an object-oriented system can inherit the methods of ancestor classes. So we are in the area of the software development. So object-oriented systems are created in software development. And this means that we have classes which inherits from each other. So the base class is person, for example, in an object-oriented system. And a special person is student, and another special person is teacher. And these are the student and the teacher have properties which are the same. So let's say they have a property, its age, how old is someone, and have a name or something different. But in a context of a university, a student has subjects, so subjects where he is learning some stuff, and he has a functionality to learn. So that's a special student class. And the teacher has skills of topics he can teach and learn others. So there's a teach functionality. So we have a common class person which has common properties for every person in the world. You can use that class. And we have a specialized persons like student and teachers with its own properties and skills. So if we go back to DITA, away from the software development, let's see how we can create a semantic structure for a parameter list, for a special parameter list which has categories and special properties of a parameter. So what we need is to document a parameter list. This is a category at first, and this parameter list can have one or more parameters, and each parameter can have some property, a name, a label, a tooltip, value, text, and selection. And what's missing here is the description, of course, where we at our documentation stuff. So if we go to DITA, and we saw that we need a parameter list, so we can go to DITA and see what lists are available. So we have OL for ordered lists, we have UL for unordered lists, and we have DL for definition lists. So that's in a generic domain, which comes from the base DTDs. And we have a special domain, it's a programming domain. We have a parameter list with parameter list entries and parameter terms and parameter descriptions. So if you go deeper, you see that we were in the programming domain. So programming domain means that we have specialized content even in the DITA standard. So PL entry, it's one parameter in the parameter list, inherits the properties from DL entry, definition list entry. And it does not have the same element names. DL entry is DT for definition term, DD for definition description. PL entry has its own elements, it's PT and PB. So if we have a look at the EDD, we find a class attribute at the DL entry element. This class attribute has a value topic /DL entry. So topic is the domain, so it's a basic domain, and it has a name DL entry. If we inherit PL entry in DL entry, we see that there is also a class, and this class is inherited from DL entry. So you see the yellow underlined DL entry part, which comes from the DL entry element. And we add a PL entry class in the programming domain. PR-D stands for programming domain. So this is how DITA itself specializes elements in the standard. So specialization is standard. So, and I think we want to have a parameter list. So I think param L is a good starting point for us, and let's see what is possible there. So we can describe one or more parameters and give the parameter name and a parameter description to that. But we don't have more semantics like a label or a tooltip or the type of values or so. So we don't have such elements in this PL entry element. And this is the documentation we want to have when we come when we are finished with our process of specialization. We want to have a category with a name, a label, a tooltip, and the following parameters are grouped in category. My category is the documentation of this category. Then we have the parameter name host URL with the label host address, tooltip, provide the host URL, a node for our a node which represents a documentation for this parameter. We have a default value which is empty. We have a placeholder which is shown as a watermark in this control. So now we can define our. Now this is the structure we want to have in general to define our parameters, right? So and labels, tooltips. It's not the same as a name, as a name is language neutral, but the label itself depends on the language. So we have the host address in English and host address in German. So this is multilingual content which needs to be translated. So let's go to our parameter list and try to implement this kind of documentation. So at first it looks very great. We have all the content we need on the right side, and we have found a valid structure. So we have parameter list, we have the parameter list entry to define each parameters. Sorry. Then we have the category name, and here below we have the host URL, the parameter term or parameter name, and all the description. But we don't have any semantics for that. And what most of DTBs or DITA implementation does in this case is to add an output class and add this semantic to the output class. And output class is defined as attribute to control the output, but mostly often it's used to also to generate or to add some semantics and handle the publication process from that. So, and what you see there, we don't have semantics, we have the output class. The user is responsible to select and assign the output class. There is not defined that the label must come before the tooltip, so we have no structure and no user assistance here, so it's still responsible of the user. You can go with that because you have all the information in there, but I think it's very complicated. So I think we should specialize this parameter list entry structure and enhance our inheritance structure, transform the standard, and add an app parent element which inherits from PL entry. So it's the same as PL entry, but has some own properties like the param name, the param label, the param description. And what we need to do in our DTD or EDD in FrameMaker is to simply define the element. It's app parent. App parent has a rule to add the elements. So we need an app parent name, app parent label, app parent tooltip, app parent description element. And as all is inherited from PL entry, we add a class, copy the class values from PL entry, and add our own domain. So we have a domain which is Crex process parents, and there we have the parameter name, or the element name again, okay? So, and this is the structure which comes from this documentation. So we have a clear structure. We define that there must be a name element, a label element, a tooltip, and there must be a description in the parameter which can have a node or a P element, and we have value text and placeholders. And so we have a very clear structure, and as you can see here in this stuff, everything which is defined here, is mandatory. So user has to use and define this information in this order, and so you can do nothing wrong here. So I think it's more user friendly than having the other structure with the parameter list. So what did we achieve so far? So we created our own DITA domain. We created a process domain, CRX process domain. We have a semantic in the elements. We focus on data and not on documentation, as we do not only write the documentation here, following parameters are grouped in the category main category. We also add semantics, the labels, the tooltips, and the name of the parameter. And we focus on users' need. Users in this case is the technical writer, to give him a great user assistance, user guidance. And as we are DITA compliant, we can share all our documents, our DITA documents, with third parties, like we can do it with other topics. The only thing which needs to be done is to share the DTDs with them also. Not only the contents, or give them the DTDs so they can integrate them in their environment, and so third parties can also use your content. We have valid output as defined by basic classes, as we have an inheritance. All the elements we define behaves like the basic class. So app param behaves like a PL entry when we go to PDF or HTML, as long as we don't override these rules. So it doesn't matter if you have a PL entry or an app param, the content comes out without any changes. And now we can, we have in DITA-OT, for example, in FrameMaker, the possibility to fit the layout for new needs. Ready for new use cases, so we can go to, we are ready for our documentation first approach, so, or other use cases. So as we have the semantic behind that, so we can go to publish this stuff to a knowledge graph-based system. But let's explain why we don't need, we only need to define our structure, and all behaves like foreign. Maybe we can use the XLIF configuration. We can do in FrameMaker, as you know, FrameMaker has support of XLIF export-import functionality. You go to File, Translation export, or XLIF export, and you get this dialog. Sorry for that it is in German, but I think if you have a DITA document, you can export it as XLIF and send it to your translator, and translator can use this standard to have an easy access to your data, to translate it and send it back to you. But when we go to this dialog, we see in the second control, XTS file. And this XTS file has a configuration for the conversion of DITA files to XLIF. And let's say we have a structure like this. We have a DL element, we have a param list, and we have our custom app parameters. What do we need to do when we configure this? And let's say we are not in a DITA environment. These elements are in a proprietary XML structure which does not support inheritance. So what we need to do is that we need to define a rule for the definition list and all its childs, and we need to find a translation rule for the parameter list and all its childs, and we need to define a parameters list and all its childs. And that's, I think, the problem a lot of the customers have who don't need to specialize, that they think they need to do it that way. And maybe they had some bad implementation of the structures in the past, and so they are burned with this topic. So, but that's the reason. Even if you add a new element in a proprietary system, you need to define it in the translation rules, you need to define it in the publication rules. So now let's go to DITA-based configuration. It's the ITS rules for DITA. And as you see, we have three translation rules that we had before, right? Here we have 9. Now we have the first 3 for the definition list. But there's something different. We have a rule which says all elements which contains the class topic DL behaves like this. All elements with the class topic DL entry behaves like this. And all the topics with all the elements with the class topic DTD behaves like this. And so we have the standard configuration, and as we saw before, we have the class element defined that it always the class element for app parent is defined as topic DL entry, programming domain PL entry, CRF process parameters, app parent. So this class contains the string DL entry, so this rule works for the programming domain and our custom domain. So there's nothing to do for the translation process. Just when we want to have a special behavior that we don't want app parent elements be translated, we need to configure it in the ITS rules. But we want to have them translated, of course, and then we don't need to do anything in this process. It just works. And this is the result, the exhilarating result when we export this. And this is the same that we have in both scenarios, in the XML with no inheritance and the XML with inheritance. Okay, so the same for the translator is the same, but the effort to configure this stuff is not there in this case. Okay, so now let's go to the part why we did this stuff. Why do we need this domain? And I call this documentation first. And we were thinking how we can develop or integrate the documentation in our own system. And we need documentation. We have a lot of customization, custom specific environments. This is done by some project managers, and they define the processes and the steps of which are in the pipeline, and they know what they do, and in that step they can configure the process and document it as well. So we thought, why should it be possible? Shouldn't it be possible that we can write the documentation and derive the configuration and the UI in the web user interface from the documentation? So write the documentation first and then have the functionality in your system. Let's see how we can do this. We have a process which translates content which is stored in AEM guides, which is translated fully automatically with people, and target languages are fully automatically imported to AEM guides, and so they are ready to publish to whatever. So we have functionality in there to keep the terminology which comes from outside, which is then defined in the process. So we get a very, very great translation result. We use this process on our own website, and Haufe translates all their documentation from English to German for German market. And this is the UI we have implemented so far. So we want to translate DITA content with DeepL. So we have some xlib settings. We want to apply SRX rules, and our source language is German. Then we have some DITA specific settings. This is one of them that a user can define if they want to resolve the variables, the key definitions within this project to give people more context, or if they want to have the placeholder content when you go to DITAWORLD. And then we have the DITAWORLD setting itself, API key, the host, and the target language where we want to use DITAWORLD to translate to. So we want to translate from German to English and French. And our configuration for this looks like that. The DITAWORLD settings here, for examples, we have DITAWORLD API keys, some documentation, some labels, some tool stuff. Then we have the DITAWORLD host URL. And this is the documentation we write so far, and this represents the UI you see here. DITAWORLD API, DITAWORLD host, DITAWORLD languages, right? So this is this documentation for the dialog. And this is, you see the structure is already ready with the parameter structure we defined before. And now we want to have some quality checks included. So we want to check if the quality of the source language is good enough that we can use the DITAWORLD translation process. And after the translation process, we want to check the quality of the target languages. For this, we integrate Concrete to check the quality and the styling of this text, so they can give us some report, and maybe they can exchange some translations defined by rules which are defined behind the Concrete system. Okay, so this is an extension. So, and what do we need to do for this? Of course, at first, we need to have a dialog like this. We want to have a quality assurance settings. User should be able to define the Concrete host, how he should be able to authorize the username password, which term base should be used, which cultures do we need to support in the translation process. This is can be read out of the context of the complete process, and we have some language checking rules and testing phase. So when should the content be checked? Should it be checked the source or the translation? And this is what the user can select here. So that's the target we want to have. And this is the documentation for that. Yeah, so we have the quality assurance part, we have the Concrete part, Concrete settings part, it's an app parameters element, and then we have the host API URL, the authentication type, and you see that there is some documentation for this parameter authentication type with a note, or that with the note that Seriously at the moment only supports the user password authorization. So this is information which comes to the documentation and the user needs so far. But before we start, we need to implement the interface to the Concrete. So of course, so there is some development to do that we can integrate Concrete in our pipeline. And so we need to have some properties. This is something which is defined in the source code. This is C#, so we are in the .NET environment. And we have properties for the authorization part. And you see that there is a property parameter mapping name. And this mapping name is defined to get a relation to our documentation. So we have the Concrete host API URL, this is the ID, and this relates to the host API URL in the context of Concrete in the documentation. So this is our interface, and maybe you see something similar when you implement context-sensitive help or something like that, and you need to have this interface between development and technical documentation department, right? So this is something you need to check. But you can also automate it and use this stuff with the documentation and generate this data structure automatically when the software is built. So you can integrate this also with your when the new software build is made, you can integrate that in automatically in the technical documentation environment. Okay, this is what we need to do. Then we write our documentation. This is the only part where we have to consult the development department and define the interface for those. This is the only part. And then we can publish our content, we can write our content, of course, and then we can publish our content to PDF, to IRBS, and to our customer portal. So quite easy. So far we have a PDF documentation, we have IRDS with a lot of metadata. And this is how a PDF looks like. It's our cover page, of course. Then we have the documentation. You see the concrete settings below, the host API, the authorization type. And then we have the username, the password, the term base, the cultures, and the rule set and language check, and furthermore, which is necessary. So all this stuff here is written by the project manager as he configures this process. And if we are here in our UI, we also have direct access to our online help, as this dialog and this topic is in relation with some IDs and the connection. And not only this topic, every parameter which is described here is available here. So we can, all this label, for example, comes out of the documentation of the okay, and all is connected. Each parameter and the dialog itself is connected. So, but what we also do is to generate the DITA map with the DITA-OT and create a JSON file for each transformation scenario which is imported in our web application. And this is the JSON file, our web application import interface. So we can generate this JSON file, put it to the upload it to our server, and then we have the complete process, translate data with DeepL, and we see here that there is the concrete documentation and the concrete field and parameter definition defined here. So we have the host API document, and we say it's editable, or it's a required parameter, or is it an optional parameter? In this case, it's required. Then we have the name, we have the label, and we have the tooltip. And you see this is language dependent. As at the very beginning of this file, there is a language parameter, which means this is German content. So we can translate our data topic, and as soon as it's translated, we can send this configuration file to the server, and we have a multilingual UI, even in project-specific environments. Okay, so let's summarize what we did so far. We have a process and the participants. We have the developer which defines the attribute classes. So it defines which IDs are needed and which parameters are available. The technical writer writes the documentation for this module or for this class and implements the interface between the software class and the documentation topic. And then we have the project manager planning and documentation customer processes. That's his responsibility. And then we have the user, which has all the information in multilingual content together in the UI at one point. No separate portal. All the labels and documentation is available in multiple languages. Okay, so let's see what the developer has. The developer can focus now on core and module development, and the only thing he has to care is to define these parameters. stuff. As we moved from the configuration to the documentation, there's no need to implement a user interface to handle all these parameter definitions. You can use DITA to configure this, and this save us a few days, or more than a few days of work to implement that logic and the user interface, and to have a cool and usable user interface. So there's less work now in the development department for that. And we have software documentation, which is context sensitive. And this context sensitive help is available for down to the parameter, or even to the parameter value, as every information is identifiable. The most benefit we have in the technical documentation is that we have the processes under control of the technical documentation, which means we have stable build processes, we have stable translation processes, and stable publishing processes. And for me, what happens in our project now at the moment is that a lot of this technical documentation knowledge moves to the development department because they want to have content translated, content published, to anything else, to anything they think they need, and they pass the technical writers with their knowledge, with their big knowledge. So we can have control of the process in the tech writer department. Then the project manager does its job, so he's responsible for customization and the documentation, and this can be done at one place. No need to switch to the application. He writes in DITA and then publishes to the web UI, and then functionality is available. And then we have the user, the customer. He can be sure that everything is well documented at that point when the functionality is there. We have multilingual content, which is part of our standard processes, and we have also multilingual user interface, as labels, tooltips, placeholders are translated in one way with the other content. So there's no need to consult the development department and to discuss how things needs to be translated. It's given by the normal translation process and by the project manager. And for me, as a CEO, I love that when documentation is finished before the function is available, and we have a completely digitalized process. We have changed the way of thinking, how we think documentation, and this leads to another completely other approach. And as we share data between the departments, we have a digitalized process here. And then we have specialization in DITA, and we have a use case for that. We have a lot of use cases, but this is one. And specialization is that what distinguishes DITA from any other XML standard, as inheritance is the basic one of the basic concepts of DITA. Users, tech writers are happy in our project with specialization, as they don't need to take care about things they don't need. And at least, last but not least, specialization means that we have semantics, and we are ready for digitalization processes and to generate knowledge graphs. So back to Charles Darwin. He said, "It's not the strongest of the species that survives, nor the most intelligent, but rather the one most adaptable to change." And I think in this case of DITA, this means that we need to fit our documents and topic types for our needs, and to spend money to maintain our data structures. It's our money. So thanks for your attention, and you find a lot of information on our blog here. You can connect with us on social media and contact us if you want to have more information and insights. We are happy to share it with you. So thank you very much for your time, and see you in the chat. Thank you very much.